Good morning children, welcome to online 8th standard physics class. Today we are going to continue our second unit in physics. So shall we get into our work? So determining the density of a liquid. In the previous class we have discussed how to find out the density of solids, isn't it? Today we are going to determine the density of liquid. So to determine the density of a liquid, you need to know the mass of the given volume of the liquid. You have learned how to measure the volume of a liquid using a graduated cylinder. To measure the mass of the liquid, first weigh the empty measuring cylinder, and then take it off from the balance and pour the liquid carefully into the pipette. Using a pipette, carefully using a pipette. So this is the picture of a pipette which is used to transfer the liquids from one container to another container. Okay, until the level of the liquid is as close to a given mark as possible. Measure the mass of the cylinder again. So difference between the two masses gives the mass of the liquid. Calculate the density of the liquid by dividing its mass by its volume. So what you have to do, you have to measure the cylinder first. Take the weight of the empty cylinder first, then add the water using pipette very carefully, then take the weight again. So difference between the two weights will give you the volume of the liquid. Am I right? Yes. So you know the now you know the mass of the liquid. Am I right children? Now you know the mass of the given liquid. Then density of the liquid is of the liquid by dividing its mass by its volume. You know the volume already. You know the volume by the help of measuring jar. Am I right? Now we have calculated the mass also. So we know the mass and volume, so that you can find out the density. So what is the formula to be applied? The formula to be applied is density D is equal to mass M by volume V. Okay children, so we know the volume with the help of measuring jar. Now we have calculated the mass. So by dividing these two, we will get the density of the liquid. Do you understand? Yes, that sounds good. Now here this table tells us the density of some common liquids. What are they? Water. The first one is water. The water's density is 1 gram per cc. Then mustard density is approximately 0.92 gram per cc. Seawater, its density is approximately 1.025 gram per cc, that is g per cc. And honey, it has 1.4 gram per cc. Glycerin 1.26 gram per cc. Kerosene 0.80 gram per cc. Turpentine oil 0.85 gram per cc. Coconut oil 0.95 gram per cc. Ethanol, finally ethanol, that is alcohol, it has 0.75 gram per cc. So among these are common liquid, which is more dense children? Yes, of course it is glycerin. Glycerin's density value is 1.26, isn't it? 1.26. So it is more denser than other given liquids. And the next comes the seawater, and next comes the water. Okay children, see, look here, kerosene's density is 0.8, but water is 1. That's why when you pour kerosene to the water, the kerosene floats. Not only kerosene, what are all the, when you pour the mustard oil, it will also float. Turpentine oil, it will also float. Coconut oil, it will also float. Ethanol, it will also float. Why? Because their densities are low, so they floats on the water. Do you understand children how to measure the density of the liquid? Yes, that sounds good. So the next topic is specific gravity bottle. A specific gravity or relative density of a bottle is a small thin walled glass bottle used to measure the density or relative density of a liquid. Okay, so before we discuss how to use it, let us recall what is a relative density. The relative density of a substance is the ratio of its density to the density of standard substance, which is usually taken as water. Okay, the standard substance will be usually taken as water. Do you understand? The relative density of a substance is the ratio of its density to the density of a standard substance. This standard substance is always water. Okay, the standard substance is always what? Water. Do you understand, children? So this relative density equal to density of a substance by density of water, that is equal to mass of any volume of a substance to the mass of same volume of the water. Okay, so let us discuss now. Did you understand what is a relative density? Now let us discuss what is a specific gravity bottle. The specific gravity bottle has a fixed capacity, which is usually 50 cc and sometimes 25 cc's, which is marked on the outer surface of the bottle. Okay, outer surface of the bottle. So this bottle, this is the specific gravity bottle. This bottle has a glass stopper. See, are you able to see? This is the glass stopper with a thin hole. So it has a thin hole inside it. When the bottle is filled with a liquid, the stopper is pushed in. Okay, pushed in. Some liquids flow out of the hole. So once the bottle is closed with the lid, through the holes present inside the lid, the water will pushed in and flows out of the hole. Okay, the volume of the liquid that remains in the bottle is exactly equal to the volume marked on the bottle. So what is the what is left out? What is the volume of the liquid? What is left out after flowing out? No, what is the volume of the liquid present in the bottle? This will be the exactly this same volume. Okay, the is the exactly equal to the volume of the marked on the bottle. So the bottle's capacity, that is equal to the capacity of the bottle. You understood? The volume of the liquid which is present inside the bottle is exactly equal to the volume of the bottle, which is printed on the outside. Either it may be 50 cc or 25 cc. Do you understand? This is the specific gravity bottle, and you have learned what is a relative density. Am I right, children? So these are the two methods to find the density of a liquid. Do you understood? Hope you have understood. So do your assignment and report in the group without fail, children. Children, report only in the group. Don't send the report to my personal number. So report only in your class groups. That's enough. Okay, children? Okay, stay home, stay safe, obey your parents, do the assignment and report in the group. Thank you, children. Meet you again.